In this example, we're being given a table of values, and that table includes values for the original function f of x and the derivative f prime of x. Then they're going to tell us some information about what the definite integral value is from 1 to 5 of our equation. And they want us to go ahead and be able to, from that info, determine what is the actual value of f of 5. You'll notice that f of 5 is conveniently missing from our table over here. So really what this is just a straight up definite integral problem, right? So they call it t's in here. I think that's one of the things that throws people in a situation like this. T's and x's, it doesn't matter. The derivative behaves the same. They sort of call it a dummy variable. So when I come to take the antiderivative of something like this, well, if I take the antiderivative of my derivative, what do I get back out? I get back out the original function. So undoing the derivative here would get me f of t, the original function, and then when I've got bounds on it, I say evaluated from t equals 1 to t equals 5. Then I apply what I just call sort of the top minus bottom method when I'm doing this. And so you would say to yourself, okay, there's my top value plugged in, and there's my bottom value plugged in. So I come in and I say f of 5, the top value plugged in, minus f of 1 has to equal, well, they told us what this had to equal back in the beginning here. They told us that our antiderivative here, this original definite integral, has to equal 13. And so it still equals 13 down on this side. And now we can use our table to figure out one of these values. So f of 1, we can grab from the table up above and put a real value in for it. So when x equals 1, the f value is going to be 7. So I come down here and I replace that f of 1 with 7. So f of 5 minus f of 1, which I now know is actually 7, that has to equal 13. And so I can just solve this problem real quick to get f of 5 by itself like a normal algebra problem. And now I know what f of 5 equals. So f of 5 has to equal 20. That would have been option C. So don't let the letter on an antiderivative trip you up. Remember, this is just a definite integral. And go through the natural definite integral steps and you will see that you can solve for the piece you're trying to find. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.